5.2 is really short, but the perpendicular bisector theorem states that if a point is on the perpendicular bisector of a segment, so if this is the perpendicular bisector right here, because it's perpendicular and it cuts this in half, then it is equal distant from the endpoints of a segment. So CA has to be equal to CB. You could also set up another point on here. So if I had to put this point F is on the perpendicular bisector, so FA would be congruent to FB. Now let's look at down here. Example 1, the line M is the perpendicular bisector of the segment below. Find X and the length of each side. So if M is the perpendicular bisector, that means that it's perpendicular and it's bisecting. So the previous theorem states that these two sides have to be congruent because this point is equal distant from MA to MB. So I'm going to write 3x plus 77 equals 6x minus 25. So subtract 3x, 77 equals 3x minus 25, add 25, so I have 102 equals 3x. So divide both sides by 3, 102 divided by 3 is, well, 99 divided by 3 is 33, so this has to be 34. So that's what x is, but it said find the length of each side. So to find the length of each side, I need to plug in 34. So 3 times 34 plus 77. So 3 times 34 is 102 plus 77 is 179. So this side length is 179 and this side length is 179 because it's congruent. The angle bisector theorem states that if a point is on the bisector of an angle, so this is the bisector of an angle, then the point is equidistant from the sides of the angle. So this means that DB is congruent to DC, and over here I could write x plus 7 is equal to 3x plus 3. Subtract x, so 7 equals 2x plus 3. So 2x equals 4, x equals 2. So this side length would be 9 and this side would be 9. The converse is also true. So if you know the point is equidistant from the sides of the angle, then it has to be an angle bisector. So if you were given something like this, if you knew that this was true, that those two sides were congruent because this was a 90, then you could write that these two angles were congruent. So 5.2 is pretty short.